All right, so today I am going to be adding um, tiling or polygon binning. There's a bunch of different names for it to my renderer, and what that is one second here. So what that is when, let's say this is my image, right? I'm rendering this whole image, and I have an object here, and let's say I have an object here. This is just, let's say they're both planes, right? See, here's a plane, two triangles, okay? And then this one has an insane amount of triangles. Like, it's like a billion triangles, all right? So 1,000,000 triangles. This one is two. That's a pretty big difference. And so how my renderer is currently working is that each pixel in the image is looping over every single polygon and then checking, am I inside the polygon? Yes, then color, which is very inefficient because this percent of the screen, right, isn't even close to this one. So there's not even any point to even looking near it. So how do we solve this? What we can do is split the screen up into a grid. Let's say like this, for example. And then each grid stores the polygons that are inside of it. So this grid has these two. This is 0, 0, 0, and then it has this little chunk of them and this little chunk of them. And so each pixel, then each pixel does is first it goes and looks at its grid, what grid it's in, and then it says what polygons are in my grid, and then it loops through those only. And then, but if a polygon is, let's say like this, what do? Well, it's easy. Then you just add it to both of these grids, and then these pixels will loop over it. This pixel will loop over it. And so this example wouldn't be too much of, well, actually, it kind of would, because there's these big chunks right here. But there's all this space here that doesn't need to be rendering all these. So it wouldn't be that much of a performance increase. So then, okay, then you would increase the granularity of the filter or the tiles, and there you go. Now this whole space doesn't have to look at it anymore. And so that's basically how it works. And I also, let me pull up I don't think I saved it, but anyways, I have a function. Let me just write it out real quick. 0 through 10. So T is the width of the cells. This is going to be a 1D example. So T is the width of the cells, let's say 10, or yeah, 10. And x0 is the minimum x of the polygon, let's say 100. x1 is the maximum x, let's say 300. W equals the width of the screen, let's say 1920. And then let's do x equals x1 x more than x1. So now we have a line that shows the polygon. So this is the width of the polygon. Then x equals 0, x equals w. So now we have, actually this is kind of a, I'll make this smaller. So here's the screen size from here to 0, and here's the polygon in the screen. And then x equals nt, Yeah, here we go. So then we can make t bigger. Let's say 100. So then t w divided by t. There we go. So now we have these, right? We have the okay, cool. So now they don't go past it. So here are our grid, is our little grid size. And so what we want to do is have the polygon only in group 1, because there's 0 indexed, so 1 and 2, 3, 4. So group tile 1 and 4. And so what we can do is do floor x0 divided by t, so they have 1, and then ceiling x1 divided by t. Or maybe not. 1, 2, 3, 4. Maybe they're both floor. 4. So we have 4. So now this is 3, 1, 1, 2, 3. And this should be 0 and 1. Yeah. So there we go. It's just the simple thing. We use floor to find the thing, because what all this is doing is it's basically finding the where this appears on this set of lines. So this would be like if t equals 200, right? This would be 0.5, because w x0 is 100 divided by 200 is 0.5. And so then you just round that down to 0. So all of these, any value here gets rounded down to 0 and just goes right here. So that's it. And then we can get the actual position of the thing here. But yeah, whatever. I've already started to implement this a little bit, but not really. But in here we have tile width, tile height, and the largest face count. And so on the GPU, you can't dynamically allocate any memory, which is a shame. So what I'm going to do is just guess how many polygons I should allocate for each tile. And I'm going to say I'm only going to allocate for the largest object. Okay. So if I had an object that's 10,000 polygons, each cell is going to have 10,000 polygons, because that object could possibly be in any one of those, or that object plus that. But realistically, you shouldn't have an object that takes up a whole cell, unless it's really small, or that. In that case, we can do something with LODs, maybe. I don't know. We'll cross that bridge when we get there. But we could also just make the tiles really small and have like a pretty close far plane. Anyways, oh, here's what it looks like right now. Let me put my thing. Documents, Rasterizer. Whoops. Oh, it's because I added stuff to the kernel. I gotta fix this first. Actually, I'm also gonna shut my window. I'm cold. Okay. Let's see here. So, negative 52 means negative 52 means invalid work or invalid kernel args, which probably means that I didn't set the... Because in the kernel right here, we have at the very end, we have the tiles, which is a uint32, and I don't think I set that because I have an allocator for it right here actually. So every time you make a new object, if the largest face count is less than the face count of this object, we set the largest face count to this object, and then we rebuild the tile array by first releasing the memory object, which is the buffer for the... It's just an array on the GPU. So we free that, the old one, and if it exists, and then what we do is calculate, see the ceiling function, or this should be floor actually. Or not, just the number of tiles, never mind. Because we need that for the for the allocator, to we can allocate it. But so it's size of uint32 times 3 plus tile count times object face count plus 1, because each tile is going to have one uint32 per per tile, per allocated faces inside of it, and then plus 1 because each one has one extra uint32 at the beginning that says how many faces are in this tile. And then we have the 3, which is just the 3 metadata things that I'm putting in the array, so I don't have to put them in a separate variable. It'll just be tile width, tile height, faces per tile. Then we create a new buffer. Tinfo, copy the info into it, cfinish, or sealfinish, and we set the kernel arg of the rasterization one and the transformation one, and then we're good. So I don't actually know what the issue is. Because it seems to be fine. Maybe I didn't build it. Maybe this is an old version. Also, this should not be this... Okay, so it does work. Okay. Also, this is an insane resolution. I don't know why it's so big. Okay. 1600 by 900. This is my current little example scene going on. Gordon Freeman, this text, which is insanely high resolution for some reason, or high, here, one sec. Context dot debug flags or equals ri debug mesh loader face count. It's actually like, I haven't checked, but it's really high, I think. Oh, okay. Oh, that was kind of dumb. I put it before I loaded the mesh, or after I loaded the mesh. Okay. $17,000 faces. Because there's 17 characters, and inside it, each, let's see, where is it? I'm really bad at looking for files. I don't know what's wrong with me. Here. Each one of these is one letter. One letter. So, yeah. I didn't think it was that slow, but this scene is, debug, frame, start end markers. This scene is running at 1600 by 1280 with 17,700 polygons at 2.4 FPS, which I think is pretty good, because we're brute forcing it, right? I just explained the algorithm earlier. It's like, it's total crap. But so hopefully after I add this tile stuff, it'll be way faster. Because No amount of micro optimizations and branchless programming is going to fix crappy algorithms. So, now we just have to implement it, which shouldn't be that hard. All we have to do is, I also made another kernel. I'm making another one to clear it because we have to clear the, we have to reset the counts back to 0, basically. That's kind of it. So this is going to be a 2D kernel int x equals get global ID 0. Also, another thing is that this is probably this is probably going to help memory access because warps or wavefronts or whatever they're called, like the groups of objects or the groups of work items, if they access memory all at the same time, which they will because they're all going to be doing like this one, this face, this face, this face, this face. It speeds up memory so fast because what the compiler can do, or the GPU can do, is it just knows that they're all going to be looking for that memory, and then in one thing they can just like send a huge chunk of that memory all the way down to the work items. And if you set the tile size to the work group size or whatever, I don't remember what it's called, but then that's basically just going to be like super, super efficient. So that's another plus that I wasn't even thinking about when I thought of this. But oh, another thing, I don't know if this is this isn't really based on any tutorial or any like previous thing that I've seen. I'm just kind of doing it based on what I have read about it and what I would imagine a good algorithm would be. So then we have uint tile width equals tiles 0, tiles 1, which is tile height. Also, I couldn't figure out how to get like IntelliSense, is that what it is, where you can see this stuff? I don't know, code highlighting and all that stuff in the kernel, and I finally did, and boy am I glad that I have it now, because I'm never going back to just like plain text programming. It's awful. Oh my goodness, I'm so cold. I don't know why I'm so cold. What else? What are these? What am I even looking for? So it's tile width, tile height, object face count. Faces per tile. Okay. I think I might need more information than that. Because I need to know how many tiles there are. Actually, I don't, because this is just gonna, I don't think I need this. Because to index something in here, all it is index equals 3 or 2 plus, no, 3 plus, because we're skipping the first 3 things, and then because it's 2D though, because I need the number of, I need the pitch of the thing, which is how many tiles are in the width of the screen. Maybe I'll just stick another metadata in there that says how many there are. Or maybe I can just stick it in the, you know what, okay. Tiles per number of horizontal tiles. Never be afraid to have long variable names. It only helps you. So y times boom plus x. And then this is going to be multiplied by uint number num faces per tile equals it's what, the third one, so tiles 2. Then plus 1 because we have the extra uint32 for the thing. So there we go. And then tiles index equals 0 return. Because all we're doing is resetting the number of faces per tile to 0. And that's way easier to do on the GPU. Because we have to do it before this, because we also have to do atomic insertion though too. Because we can't have them just adding the things on a... Okay, this might be a little tricky. Oh man, I'm so tired. Why is ChatGPT? I don't, for some reason, ChatGPT is my default, my home page. I don't know why. I think I did it a long time ago, but I'm going to get rid of that real quick. No. Okay, whatever. Two threads, T1 and T2 both execute the code snippet, but when I try to do atomic compare exchange, I don't know what that, I think that's what that means. T2 has to wait for T1 to finish. Suppose T1 runs first. The old value of 0 changes to 1 automatically. Oh, okay. You can create a program scope variable if you use SuperSO2. I should read the questions more. Let's see. I gotta stretch. I might ask the GPT because it's kind of pissing me off. Okay. I think you can just do atomic add. It just works. Unless you have to declare the number volatile, which I saw, but I don't know if you need to. So this doesn't matter because these aren't going to be interfering with each other. But this one will, because I think I started the code somewhere down here at the AAB section. Yeah. If we have a thread, let's say, because this is a 2D. I think it's 2D. It should be 2D. A 2D kernel execution that what it does is it has the work groups boop, 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 for each triangle in a mesh. Triangle, triangle, triangle. If, let's say, these two get executed at the same time, and both of these triangles happen to be like this, right? And they're both inside of this thing. They're both going to try to add to the counter at the same time, the number of faces per tile in a certain tile, in this tile. And so they're going to try to do that at the same time, which can cause a race condition, and then maybe one of them fails, and then it only goes up to 1, right? That's bad. And then one of them tries to insert itself into the index array, and then it misses, and then everything is messed up, and your computer explodes, and then yeah, it's bad. So yeah, that's not good. So what we're gonna have to do is also do atomic insertion, because that's like when you're adding something to an array, I think, or setting a value, because we have to set a value. Increments a number, then it uses that incremented value to set a value in a array. This would cause race conditions because this is because all of the work items are doing this too. What do I do? What I'm thinking is I'd start out, like, before I increment it, I grab the value, and then I set where it, but still, it's like, this is annoying. Can I use like an atomic function or something? Atomic bulletins. Oh, so it'll return the value. This is useful. So it returns the value as soon as you increment it. So then there won't be any race condition from adding it and then retrieving the value. Atomic uint. This is annoying. What if it's part of the same array? The increment and the assignment. Okay. The thing is, if I could use Google to solve my problems like this, I would. Right? Like, I don't want to be using the ChatGPT. But look, look. This looks correct. Looks fine from what I've seen online, right? And you know, at a certain point of trying to use Google, you would understand too. All right. Whatever. I try not to use the GPT too much for stuff, but you know, it happens sometimes. Tiles. Then for int y equals 0, or y equals tile y min. Y is under tile y max, or it's under equal because let's say we have a min of 0 and a max of 1. It would only run once, so we have to do, so then y plus plus, and then we have x, 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 x. And what you might notice is that, hey, this is a square, and triangles are not square. Which means, if I have a triangle like this, boom, and the grids are like this, boom, 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 the triangle will be included in here. Because otherwise, we'd have to basically rasterize it, right? We check every pixel, or check every pixel here. If the triangle's inside of it, then add it. That's just rasterizing, basically. And so, it's okay to have around half the triangles of these things include it and check it, even if it's not. Because honestly, I don't care that much. So, oh well. Okay. Does this have a description? I can't really like highlight things. Atomic. Is there any description of it though, or no? Okay, whatever. Uint. These should all be uints actually. Now that I think about it, because they're never gonna have a negative value. Uint tile width equals array. What's the difference between atomic fetch add and atomic increment? Saturating increment with a max value. Atomic fetch add. So increment the value exceeds the maximum representative value, so it's 0. Change value. Okay. Well, I don't really want to add any integer. Oh, it's more modern. Okay. I guess I'll listen to the GPT. Whatever. We're using this. Tiles 0. And then what is it? Faces per tile, which doesn't really matter. Per tile, which will, because we want to make sure we're not we're not assigning past that number, because if we are, then we're gonna corrupt the memory. So we gotta watch out for that. Excuse me. So floor, per face. Oh, it's cur r face. Cur r face. Min screen x divided by tile width. Is there no floor function? What? Why is this ambiguous? Oh, do I have to just tell it what it is? Unit 32. I think, right? What? Or no, I want it to be a float, actually. Okay. That's better. Max. And then boom, done. Now we have to just find the index. Unit tile index equals, let me go up here. Oh, we're gonna need to know this too. The number of horizontal tiles, because we need the pitch. For some reason, I didn't think I needed that. Okay, I should have put that in the metadata, and I actually just might, because that makes a little more sense. Because if they all need it, then... Because, you know, we're passing all the data anyways, why not just put it all in the same array? Boom, done. Wait a minute, I gotta check my phone real quick. Okay. So it's gonna be 4 plus 4 plus. Copy. Go in here. Paste. Copy paste is one of the best inventions I think I've ever seen ever. Tile index. Oh. Zoop. Or I guess no, it's the tile array index, because it's not actually the tile index. This is the tile index right here. There we go. So this is indexing the first element of each one, which is the number of for num faces in current tile, which is now incremented, I think. Before the add, so we can just do just add 1 to this, or no, because we don't have to do that. All you have to do is tiles right index plus this equals and then the index to the current face, current renderable face, which should be face index times 2 plus renderable face offset. That's a mouthful. Boom. And then we do this again for the current renderable face, which are we even? Oh, it's up here. Okay. Maybe, or current renderable split face is what I'm saying. Which is when you have to call a polygon. Well, let's just start with this one. Excuse me. All right, so I think we're done, actually. Really. Now we just have to. Oh, I got to remove that extra. Oh, I did. Okay. And then. Oh, I still have to make the actual kernel for the thing. I'll call it the clearer kernel because it clears the thing. Clear tile array is what it's called. Tile clear kernel, which doesn't exist. I have to add that. And I have to go to the constructor, or not the constructor, but the default thing for this. Stick another null in there. There we go. Now we just have to run this. We have to run this somewhere. We have to run it before we transform anything. So wait, what? For some reason, I'm loading the missing texture every single frame. That's weird. And very strange. It already does it right here. Okay, that was super weird. Context default texture. That doesn't even exist, does it? Oh, I guess it does. Okay. Anyways, how do I run a kernel? I always forget. Copy. Paste. 2D array, global work. Oh, I need to, I'll do C global work size. Wow. Okay. C local work size equals the number of horizontal ones and the number of vertical ones, which is just oh man. Oh, I need that one too. You know what? Too easy. Too easy. Too easy. I am the next Leonard Euler. Oh, this is the global work size. We have to do this though too. Okay, this is what I was looking for. Because it has to be equal. It has to be a multiple of it has to be a multiple of the local size. Local T size. What is that? Local transform size, which is f-min square root. Oh, okay. So if it's if the number of tiles is less than, it's like 16, less than the local group size, then it's just and this should all be C for clear. Says Y. Context dot opencl dot number of v tiles. Oh. Okay. There we go. Error in queuing tile clear kernel. For some reason, I don't have the name of the kernel in this error function. In queuing transformation kernel. Error in queuing. There's no error check here. Whatever. Okay, so oh man, how has it been 50 minutes already? Jeez. Let's just try running it right now. Oh wait, I didn't set the kernel arg for the okay. Let's just try running it. No warnings or anything. Something happens. And this looks bad because that means that there's probably an error and then it's just stopping in the transformer. So what I'm going to do is return here. What is the issue? I don't know why Green Day is stuck in my head right now. If is more than number of horizontal tiles, if x is more or equal, return, and then anyone for y too, but I probably should just stick that in there too. For vertical. Because it could be different. It will be different. It is different. 5. Zoop. 5. Zoop. 5. 5. Wait a minute. Oh yeah, okay. Except for like, oh, is it 0 index for a second? But it wasn't. Num of the tiles. Okay. There we go. Okay, that was the issue. Yeah, OpenSCALE does not really like when you are. It's not a big fan of when you write outside of an array and then mess stuff up, which I don't think anything is. But here we go. So now we have our example scene running, and at a staggering 2.5 FPS. Truly a testament to modern engineering. And oh wait, but also I'm returning here. Let's forgot about that. Okay, cross your fingers. Crap. Whatever. Not like I care. Actually, let's do a min max real quick. So min or max 0 number of So this is gonna make sure we don't write outside of the range. Is it F max? Okay, it's F max. F min. Number of tiles. What is the issue? Oh. Okay, let's try that. Oh, what the heck? I guess, wait, does it work? Why did it just show up? It just started rendering stuff. It rendered one frame. Okay. I guess this doesn't mean anything to me because I don't know how many tiles there even are. So let's look at that first, too. Number of horizontal tiles. Number of vertical tiles. There are 100. Why is this number changing? This should not change. That's weird. 168. Oh wait, what's the width of them right now? I think it's 16. I think. So wait, let's do some math here. Calculator. Divided by 16 is 100. Okay. Oh, well, that makes sense. And then 900 divided by 16 is 56. Floored is 56. Which, that's not what 68 is equal to. Which is a little bit interesting. And also, why is it changing? Let's check roll here. Okay. How about this? Let's debug a bunch of stuff in here. Hello. You know what? We'll just return. Easy. Oh wait. Let's exit. There we go. Exit. Easy. (16 by 16). There are 44 faces. There are 100 tiles in the width and 56. Okay, that's right. 56 is right. Now, how did 56 get turned into 60 something? No. Well, so after we load them, then we'll return. Okay, so it doesn't change. How many bytes is this actually? Because a unit 32 is 4 bytes. Hello, calculator. 4 times 17,060 times 100 times 56. Ooh. 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 Is this megabytes? 300 megabytes? Or is that kilobytes? Ooh. We got gigs of VRAM. We'll be fine. That's kind of a lot. Also, why is this only showing me 3 meshes? Oh, because they're not, the mesh count isn't more than the previous one. All right, so. I'm cold. Still. Oh, goodness. Maybe we'll do like divided by like 5 or something. I don't know. It's missing normals. I don't really care though. Oh my goodness. Okay, so these are fine. What about let's print from the. I should keep this return actually. Or no, I shouldn't. Whatever. Kernel. I'm just gonna remove the print from this one. I'm a super genius. Don't know why I didn't think of that first, but okay. So, let's just check that all these are intact. So tiles 0. 4, 3, 2, 1. $62. That's just weird. Oh, wait a minute. It starts out at 6. Oh, do I still have the What am I rendering here? What is this? Because number one, this is not the width and height of the tiles. I don't know what's going on here, but it seems to be solved by. Oh, okay. Well, I'm an idiot. Okay, I forgot this is here. This is correct, right? This is correct until we render a frame. So I think that I'm just incrementing the wrong thing. This is the wrong. Okay, never mind. Okay. Kernel.c. Oh. Okay. So let's go here. And then what's happening is after I increment this incorrectly, then it's not checking this one because this is the wrong value. So let's see here. Oop, this is 5. Isn't it? Yeah, okay. Is that problem solved? Oh, yeah, okay, problem solved. Sure. Then we can delete that. Added triangle tiling or whatever. We can delete this. It's like nothing even happened. So now all we have to do is go to the rasterizer, and then we have to get these should all be uints, but this is before I realized that I should probably be using more valid type names for stuff. So I might fix that later. Uint tile x equals blah 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 int tile y, and then we can do the exact same thing we did for this, but instead of this, we can do I am freezing because I had to go clean the snow off my car, and it is what's the temperature? It is 27 degrees outside. My fingers are freaking freezing, and they're itchy now. Whatever. What was I doing? Oh yeah, adding it to the rasterizer. So this is gonna be the pixel. So just pixel x, pixel y, and then we have to grab this stuff. This will be useful later, anyways. Oh man, nothing broken so far. Let's check. Nope. Some water. And I also got some baby food. It's delicious. This stuff. It's so good. It's got yogurt in it. It's like applesauce and yogurt. They're eating good, man. Anyways. So, instead of doing this, which is currently, we're looping over, how many polygons was it? Like 17. It was like 17,700 polygons times 2 times 1,600 times 900. We're basically looping over 50 billion triangles, 51 billion triangles, right? And 90% of those don't need to be happening at all. So hopefully if this doesn't improve performance, I might actually like go postal or something, because otherwise I don't know what to do. So we have to get this so we can find the tile index. Oh goodness, I love postal too. It's so fun. That just reminded me of it. All right. So, uint number num faces incur tile equals tiles. Okay. Okay. So 0, or actually face I can equal 1, and then do this, and then we can just do tile array index plus known faces in current tile. Or no, wait, I'll just do this, then plus 1. Moment of truth. Didn't work. Do 3, 4, 5, 6, 7, 8, 9. Okay, so tile. There's a hawk outside. Tile width, tile height. I can hear it. Faces per tile. Number of horizontal tiles, number of vertical tiles, which I don't actually think we need that one. Oh no, we do, because it's right there. Then tile X, tile Y, tile array index, and number of faces in current tile. Did I put a new line? I didn't. So this is gonna spit out a bunch of garbage. Zoop. Or I mean, hopefully it's not garbage. Oh. We're not even getting to that. Huh, okay. Well, let's try this. No. Oh, here we go. So, tile Y is 745 million, which I don't think is right. Let's see, faces per tile. 16, 16. 0 is definitely right. So these are both right. This is right. This is right. This is right. Oh wait, actually, maybe I'm just stupid. Width, height, faces per tile. Bop, 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 bop. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. Oh, okay. So that's just okay. That was just a on an instantiated value. This looks right. Right? Yeah. I mean, actually, it doesn't because only. Wait, no, it does. Okay. 1, 2, 3, 4, 5, 6, 7. Oh, let me just put in the pixel coords too. So pixel X, pixel Y. Hello, what is this? Interesting. Oh, it's tile array index. Oh, so I was right. So that was just tile array index. Which might be right, which I don't even know why I'm debugging that because I can't read that. I don't know what that means. Really. I guess I could extrapolate data from it, but here are the pixels. For some reason, Y is always 0. Is number of vertical tiles 0? No. It's right there. What about this? What is this? Just, 0. Well, I guess for all of these, pixel Y is pretty low. Okay, I bet that's fine. Tile array index. So that is equal to 700 million. Which might be right, because it's 300 times 4, which is 12. 1 gigab... I don't know. All right, so let's do some math here. What if I just do tile 0? Let us do that. Will it do something? No. No. Can I not read from this? I feel like I've had this issue before where I can't read from a array. It also just crashes my thing. Yeah, I can't read from it. Oh. I can for 1 frame. Apparently. But this is definitely not the whole number of pixels. All right. I'm OBS just crashed, but it's okay. Because the video OBS crashed again, apparently. It gave me an encoding error or something. I wonder if it's because I'm using so much VRAM. Okay. 103 is definitely the wrong answer. You know, we should probably be looking here. And then printf. Let's see. So if we're at the first tile, so we're at 0, 0. It's 5 plus 0 plus, or 0 times 0 times 0. So this is going to be 5. Tiles index 5 equals 0. Let's just print that here real quick. Tiles so I can find it, and then tiles 5. Oops. I always forget I don't have to rebuild when I just make the kernels, but 103. That is not 0. Oh my god. What do I hear? Oops. Okay, that's 0. That's 0 also. Huh. This is weird. This is weird. I don't think it's the same question. Oh, okay. So this is just dumb. That's what I thought. Race conditions, overriding work items. All right, so let me check my code real quick. Boop, 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 boop. My mouse sucks so bad. I need to get a new one. Look at this thing. It's ancient. It's because my other one broke, and I never got around to buying a new one because I'm cheap. I mean, like, I have money. I just don't like buying stuff. What I'm thinking is that the another one of these is overwriting the other one, and so when we print it right after, it's gonna say that, of course, but it's gonna change later. That's what I'm thinking. So, well, no, because why? This should all be 0 in the first place. Oh my freaking god! I don't know. I don't know. Oh goodness. What the hell? I am running them before each other, right? I mean, I'd have to, because otherwise the prints would be out of order. But, yeah. tile clear kernel. And then I am running seal finish on it, so. Jeez, I'm cold still. And then this stuff is being set to, like I'm setting the kernel args fine. Number 34 is the tiles mem buffer, I think. Let me actually check that real quick. Yep. It's so weird. I don't want to ask the GPT, but this is the kind of issue that you would ask the GPT for, because it's such like a hidden issue. But I don't want to. Oh my god. Global uint tiles. Global uint tiles. So they're the same type. What about or what if one of the kernels is running before the other one and then doing this stuff? So okay. What I'll do is I'm going to delete. I'm just going to return before this. So then we're just going to skip that whole process. Please, 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 please. Oh my god. Okay, sweet. So, it's this. Thank the baby Jesus. So, because I was about to go insane. This is doing something wrong, because there at the first one, there's definitely the first tile, there's definitely no oh, excuse me. Oh. There's definitely not 103 polygons in it. Wait a minute. This seems more accurate. Because tile array index plus num faces in current tile. I didn't add one. And if I remove the skybox, let's see. I'm just gonna make it like really small. Or can I just make it not render? Scene actors 0 dot active equals 0. I don't know if this even works. I've never actually tried this. But... And then... If the face is inactive, it should just return, I think. It should. If... Oh, it's not even a part of this, so I can't... Okay. Or no, because it doesn't even run. If it's not active, it doesn't run the transformer. Yeah, see? So that, okay. Please be 0. Please be 0. Please. It's not 0. Okay, this is annoying. It's not 0. But I think we do need to add 1 to here. Because it has to start after this. Zero, 1, 0, 1. This looks more accurate. 0, 1, 0, 1, 0, 1. And let's do the X and Y of the tile. So X, Y. So these are all different. Wait. What is 6? What am I printing here, actually? Because I don't remember. Oh, tile 5. Yeah, okay. $32, 26. Does $32, 26 appear here again? 32, 26. 32, 26. 32. Because if it does, at least we know the increment works properly. 32, 19. 32, 17. 32, 23. 32, 13. Is this going to take forever? Okay, this is going to take forever. 200 polygons in the last... That's a little strange. What if I just make the size of the things really big? So there's only going to be like a handful of tiles. I only want 1 tile, actually, so let's do 1600 by 900. There are 2, apparently. But this seems to be working, mostly. I don't know why it keeps... jumping up to 9,000, but what if I do like 601? I think that's just a math mistake. No? There are 4 tiles. Why are there 4? What if I make it times 2? What? Times 1.5. Whatever. Oh? 1. That is actually what it's supposed to be. Well, but why aren't we... What if we only do, what if we say, if... Oh, wait a minute. Okay, never mind. I thought we were overwriting a variable name. If if tile x does not equal 0 or tile y does not equal 0, we're going to return. So we're only going to render that one tile. See if that works. Nope. Something is going wrong, which I think is this. So what if we just return? Okay, so we're actually doing something. Tile array index, which should equal 5, plus number of faces in current tile. Oh, wait, this is face I, isn't it? Maybe. It's a little awkward, maybe? Nope, still not working. Okay. Sure. Let's do this. Let's... Okay, that is nowhere near close to 5. They should just print 0. Okay. And then... this should also be 0. What? Number of horizontal tiles. Oh. Wow, what do you know? It's working. Wow. Who would have thought? Oh. Oh my god. Oh my god, we have something. We have something. Let's do 32 by 32. Whoa. Check that out. Oh, uh-oh. We have something though. What if I bring the this back? The skybox. Nothing. What if I only render the skybox? Let's try that. Huh. We're getting somewhere though. We're getting somewhere. That's a good sign. What if I do a plane? What if I just do the emoji? So now we only have one object, which is the plane. That's not a plane. So this should only pre-printing. Let's see. Renderable face offset. What the hell even is that? I don't know what that is. Okay, whatever. Oh, I know what that is. Never mind. It's the location of that face in the renderable faces array. Boop, 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 boop. This should be only doing 2 numbers. That is not 2 numbers. What am I doing wrong here? If... Oh, did I not even read this right? Or if scene actors actor index dot... Did I just like hallucinate that that's what that said? That it said if active does not equal 0. Okay. That's kind of funny. Oh my god! It should actually be 4 because it's a 4-sided shape. And guess what? We have 4 numbers. It's the 2 in the front, 2 in the back. Okay. 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 So something is working. Let's look at that again. I feel like this still shouldn't be 200 FPS. I feel like it should be way faster than that, but currently we're only rendering one face, which I think is interesting because there's more than that. What if I increase the resolution of the faces to like 320? I wonder if that'll be faster. That is way faster. But now where's the guy? About 128. Still not very fast, but so I think that was just fast because my code was breaking. Okay, so we have that guy. Where are the other ones? Where are the rest of them? So we gotta get boom. And then I'm gonna grab all these. Okay, so number 1 is at 2 through 6, 7 through 2, 2 through 6, 0 through 3, 2 through 4, 7 through 3. I'm gonna make actually markers like lines maybe. If pixel x equals, if pixel x modulo tile width equals 0, pixel color equals red. So then, or pixel y modulo tile height equals 0. We're going to do pixel color equals 0x ff. Let's do white. White looks cool. Okay, so here's the grid of tiles. If I change it, it should so this should be twice as many tiles. All right, cool. And then what I'll do is, in the kernel, I'll say if number of, I'll set the background to like green or something. If number of faces in current tile is more than 0, then pixel color is going to be equal to ff 00 ff 00. So bright green. That's pink. Is it RGBA or is it? There we go, green. But why are they all like that? Oh. Oh my god. This looks right. Dude, this is so cool. But I think it's opposite. Because it's not over there. I think the tiles are actually flipped. Like, I think the X is flipped. So what if we do this? One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So there's like 26. Oh, it's in reverse order now. That's why. So I have to do minus minus. Then I have to do max to min. Or you know what I can do? I can just swap max and min. That's easier. Okay. This is kind of right. Not really though. Huh. We can see more of this guy, at least. What if we try the rest of them? The rest of the objects. So, boom, 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 boom. Let's see what that looks like. Uh-oh. All right. So we're doing that, and then Gordon's head is the next one. Gordon Freeman's head. Of the two objects. So I don't think that worked, actually. Interesting. Hmm. Because I think this is flipped. I think X and Y are flipped for some reason. So what? Oh yeah, Y is flipped. X isn't flipped. What if I flip X? What does that do? So that's exactly the same as what I had before when it was like just flip the grids. I'm thinking that maybe my function is wrong. All right. Let's try making it just one. Only one box. Try that. Oh. Interesting. We have half of Gordon Freeman. This is his head. This is interesting. I think. I don't know. Why is there only one Gordon Freeman? Or one half of Gordon Freeman's head? That's weird. Also, is this why there was 2 tiles? It said. No. Okay, so that was right. Goodness gracious. Zero 2 4 6 8 0 2 4 6 0 0 0 0 1 0 0 0 1 0 0 0 1 0 0 0. That's X-Min X-Max. Why is here, let's do this. Max X screen X max. Oh, it's I don't know why. Okay. Here we go. Boom. Boom. Oh, wait. Is it because there's negatives? Where's my... Because current min screen X divided by tile width, which is 1600. So Negative 11 divided by 1600 is negative that. And then that floored. How do you floor a negative? Floor function. Floor function of negative 0.008. Is that what it was? 6. Floor of that. This is super annoying. But it doesn't matter though anyways. Is negative 1. So it's negative 1 because it goes down to that. But that doesn't matter though because I'm doing F max, which will negate the negative. It'll put it back to 0. So this should be 0. Min screen X, max screen X. Why is it 1, 0? Goodness gracious. So let's do this. So now they're both 0, I guess. Does floor return an int? I should probably actually check that. Let's see. Let's do int. Yikes. That's a big number. Okay, so the floor of, what if I do uint? Because this is kind of looking like an overflow or an incorrect type thing. Nope, it's still that. Okay. Well, let's stop it when both faces are showing. Okay, there. So I think this is just a printf error because yeah. Unless it's because min screen X is an integer and I need to type it to a float. What if I just type them all to floats? Because tile width is a uint. Okay, this is looking much better. I think that might be what it is. If that's just the issue, then I'll be very happy because that makes my life a lot easier. And then I'll do this as a regular int too. And then this as an int. Signed int. Or I can just do this as a uint. And the rest of it's fine. What? Oh, excuse me. Is ambiguous. Why? Whatever. Yay! Oh my god. And then, am I still flipping the thing? I'll unflip this. Okay. And now let's put it at divided by 2. So we'll have 4 grids. Let me... Let's flip the thing again. Let's try that. Let's just try that. Oh my god. It's kind of working. Kind of. Okay. What about, well, I set it to 32. Okay, well, we're definitely having some issues here. But it kind of works is the good part. Oh well. Where'd you get the idea, though, of what it's supposed to be doing? Okay. I wonder if this is because of the atomic issues. Let's see what the GPT thinks. Is safe. This is not safe. Which this isn't an issue because we. Oh, actually, it's not an issue. No. Oh, wait, that's true. We gotta fix that. Okay, that's something. Okay, so that really shouldn't really be an issue because that's not something that affects this. My question is, why is that one over there? Why is this one being lit up? What is here? It's actually matching up exactly with this one, actually. That's weird. One, two, three, four, five, six, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay. So there's 7. Let me see what number of horizontal tiles equals. Six. What do you know? That might be a problem. What is it? 256 divided by... Oh, no, up the other way. What? It's ceiling. Why is it 6? Does ceiling not work or something? 100? What? Oh my freaking god, dude. $100. $106.6. Okay, I don't know why it's 100 there, but whatever. It's not 6 though. Does the ceiling function just not work? Oh, or is it because this is being an int and it's rounding down? No. Oh, wait. Yep. Okay, that's what it was. It's freaking types, man. Worst thing ever. Okay, so now this one isn't lighting up, but still it doesn't work. I was hoping that would just fix it, but whatever. Okay, what if we try the skybox? So I'm curious about that one. Interesting. Interesting. What if I rotate the skybox? Okay, this is because of the split faces, I think, when it's going past the thing, so that's okay, because we're not even working with those yet. Why is it not showing up in the other ones? I think that's a little strange. So let's do this again. Printf. Min-max screen height. Min-max tile. It goes from negative 800 to 800, which just isn't true because what? I'm pretty sure that it's more than that, but okay. What if I do this? What if I make it really small? Well, I guess it's because it's the screen X. And the middle of the screen is 0, I think. Yeah, the middle of the screen is 0. So it is negative 800. Well, no, because why isn't it? Why is it? Well, that would make sense why it's only half. Does that exist? No. Width divided by 2. Okay. Am I onto something? Oh? Am I onto something? Because the middle of the screen is I'm gonna put this guy in the center of the screen. So 0, 0. Okay. And this is looking much more reasonable. Still, I don't know why it sometimes like cuts out like that. It shouldn't be doing that. What if we bring Gordon back in here? Let's try his body this time. There's some of it. What about the text? What about the... Yikes. But yeah, that would explain why the boxes were offset for this guy, because you know, the colors, or because the what was it, 60/40? It was around that. And then is Y broken too? Is Y flipped too? Or is Y just flipped? Oh. 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 What if I do 1? That'd be interesting. Let's see how that runs. Yep. Okay. That kind of messed up. What about like 4? Okay. You know what? We can go back to... Oh, because that allocated so much memory. I totally forgot that. Ugh. Whoopsies. Okay. This seems to be fine. And then let's add in Gordon. Gordon, what are you doing? Oh? The Freeman? Okay. And then what we can do is just flip it after. You know, we can just, I think IDX we can do is just, height minus this. There we go. Boom. Okay. And then if we do the skybox, we can't see the color anymore, but maybe I'll get rid of that one. And then let's do the text. Let's try the text. Oh. And that might be slow because of the printf. That better be why it's slow, please. I don't want to have just gained an extra FPS from this, dude. Please. I think that's all of it. All the printf. Dude. It actually works. It actually works. Oh my god. No way. Oh my god. Oh my god. So this is a 17,000 polygon scene, by the way. Oh my god. This is 94 FPS. What about if we make it 64? Let's try 16 actually. Will it be faster or slower? Slower. What about 64? Faster. What about 128? Slower. Okay, so 64 seems like a good spot. What about 160? 64 is 25. 900 divided by 25 is 36. So let's do 64 and 36. So it just matches with the okay. So now it's matching with the resolution. Like if I go here. Look at that. I can't believe it. Oh my god. I'm gonna get a new. I gotta get a new GIF for my website. In the README. Because this is 100 FPS. 100 FPS instead of 2. That's what? 500%? 50%? What is So from 2 to 100, 40 times performance gain. I'm actually amazed. Let me take another video. This is incredible. Like honestly, I'm actually so surprised I can make something that actually works, man. Dude. Okay, I'm actually very happy. I'm very happy. All right, cool. I guess that's it.